Hello, everyone. It's very nice to see you again. This time, we're going to focus on how to create a stand, a pedestal for the clock. And in order to do that, we have to design it on a piece of paper, something simple, something efficient, something that looks good and, and adds to the aesthetics and appeal of the clock. Okay, and so I'm going to give you a few minutes, okay, to think about it, what needs to be done. The clock face, you finished it together with all of the parts and including, assuming that the mechanical gears, they're all mashed and it's operating right now. And also you did have the arms and everything is constrained and in motion. You have seen everything is working. Now this is the time when you printed, 3D printed the clock, to put it on your desk or table so that it stands up, okay, at a balance. And something, this stand, this particular support of the clock, that's going to keep it upright, can be done very, very elaborately, can be done very fancy way, or can be done very simplistically, very, very efficient, okay? But either way, it has to be proportional, it has to be aesthetic, it has to be appealing. So I'm going to attempt to draw something, and I just started Inventor the same way. I created a new part drawing, and I'm just like moving on my cursor over the origin folder, the plus button on the origin. I click on the plus button, and all the files comes out. I'm going to select the YZ plane, click on it. As soon as I click on it, the icon appears on my screen to create a sketch. This is the standard procedure with the Inventor. Always you select a plane that you want to work on and then start a sketch. Okay, so we have the sketch in front of us, and now we need to get some dimensions. Okay, this entire clock is about 12 inches diameter. Okay, so the stand is going to be perhaps within 6.5 inches, maybe 7 inches. Okay, and the real question is, how are we going to support the stand? I mean, when you put the stand simply on the when you put the clock on the stand, how are we going to support it? How are we going to rest it and secure it? So that's the question. And then I realized that the design that we enabled us to create some extra additional unused axles on the back. So maybe we can use those axles and to insert through the holes of the stand that actually keep the clock at a certain angle. We don't want the clock to be 90-degree angle because we're going to look at it probably from different angles other than 90 degrees. So we're going to tilt the clock a little bit, maybe 75 degrees, not 90 necessarily, or 85 degrees, okay? And the next question to answer is how wide the base is going to be, because base is important. If the clock is going to be as high as 12 inches and tilted about 85 degrees, then the base should cover probably around 6 inches, right? That would make sense, okay? 6.5 inches maybe. And that's, we can adjust that later on if we find it not so proportional, okay? So 6 inches by 6.5 inches, I think that makes more sense. And just give it a try and see how it goes. Okay, so I'm selecting the line command, all right, and starting a line from right at the center. Maybe I should go to the left this time. Okay, I'm going to go to say 6, enter. Okay, and I'm going to just measure the approximate height. Okay, it's going to be, an angle is going to be 85 degrees. maybe let's go with the same 75 degrees. Okay, and about say yeah, about 3 inches high. So I'm going to type 3 and tab key and 75 degrees and enter key. Okay. Now there should be some thickness. I'm going to be creating this thickness by after the offset command. First of all, this is a sharp angle. It's not necessarily to be something that is more aesthetically appealing. So I'm going to change that sharp angle as a rounding. So I'm going to use the fillet command. Okay. And let's still fillet should be, say, about 2 inches. Okay. I'm going to choose these two lines. Well, this is too much. I'm going to just, all right, perhaps 1 inch. No. We'll do this one more time. Let's try 1 inch. And fillet command. And let's select the item. Okay. Yeah, this is about right. And now we're going to draw another line from the top of the line. It's about perpendicular and about say 1.5 inches or 1 inch. 1 inch is fine. That's right. Okay. Enter. Now we're going to offset this. And let's offset this like let's offset it to 3/16 of an inch. Okay, the entire line is being offset at 3/16 of an inch, 3 divided by 16. Enter. Okay, we need to draw the lines at the end of the closed polyline. Okay, enter, enter. Okay, so this will be extruded. Let's extrude the entire thing about 6 inches. Okay. And I'm going, before extrusion starts, I'm going to finish the sketch and band it entire system. Okay, and then select the extrusion. And I will go with 6 inch. Okay, extrusion. When you do things like that, sometimes I want you to be curious about why is it moving, extruding in one way and not other way. What if I wanted to have it extruded in 2 directions? Okay, so let's enter here and ask the same question to the, where is the extrusion dialog box? I wanted to go with a 2-way extrusion. Okay, there it is. And okay. Good. And of course, if you put the entire clock on top of this, it's not going to hold. So we need some holes, all right, in the surface. All right, so because there are 2 axles and I want these to insert those 2 axles, okay, through the holes. And I already went back to the clock face and I measured the distance, okay, and the distance between 2 holes is going to be about 3.3¼ inch. All right, so I'm selecting the surface that I want to work on and creating a sketch based on the surface, okay? And now I want to draw a line to designate where the center of the line, the surface is. This is approximately where the center is, okay? And also I want to designate the line behind that surface, okay? So now we can create our hole. All right. The size of the hole should be slightly larger. And if memory serves well, I checked it out back also that there are 0.5 inches, okay, diameter. So I'm going to make it a little bit larger, 0.52 inches, okay, diameter. So what's the distance? 3.25, 3.25. So I'm going to use offset command. Mhm. To the left side, okay? And I'm 3.25 divided by 2. I'm going to put the mathematics behind that. So 3.25 slash 2, enter. Okay. And we'll do the same thing again, offset command. And 3.25 slash 2. I'm glad that Inventor is capable of making this much better mathematics. And now we need the circle. And the circle will be approximately 0.52 diameter. So I'm going to type that, okay, 0.52, enter. This needs to come down a little bit more. So I'm going to use the move command from where it is. And there's a move command right here. Okay. Come down a little bit below where it is. A general rule of thumb, okay, with any software is that if something doesn't work in the first time, sometimes doesn't work first time. You try it again until it works. If you're sure that you're doing everything right. So we're going to make a copy. This circle, it's going to be whole, okay, from here, copy this circle, and from the end of the line to the end of the line, okay. All right. So we are ready to extrude this. Just to make sure that these are the correct hole sizes, it looks a little bit too large to me. So I'm going to go back to part drawing and check it out one more time. But basically, this is the design and the extrusion. We're going to finish the sketch, and we're going to go back to extrusion, and we're going to select the cut type of extrusion, okay? We're going to select, click inside each one of those circles, because it's a cut. It's created, okay, perpendicularly, and now we're going to OK it. Okay. And we need to save it obviously properly. Okay, so this is right now in front of us the back face of the assembly drawing. I checked it out. The diameter of each one of those axles are 0.5, half inch exactly. And it's marked this way. You can see it yourselves. And distances are also measured accurately between two centers, 3.25, and this is correct. They measured also earlier. So I think we're ready. I'm going to finish the sketch, and we're going to insert. the stand over here. And before we do that, I'm going to just change the angle a little bit. Okay. And we're going to just go to, this is assembly drawing, so that's why we can just simply place. So I'm going to return back to assembly drawing on the top right hand corner, and I'm going to click on the base command, okay, and the place the stand, pedestal. All right, so Google Drive, whether it is on or off, okay, there are two important things. We're gonna have to keep the Google Drive on if you're gonna need the files from the Google Drive, not from the OneDrive or any other drive, okay? So that's what I did, and now I'm going to have to go and insert the pedestal drawing. Okay, so I'm going to just stop this pedestal design here at this point. I suggest you to design and build your own pedestal, and you can make it look like mine, or you can just originate it. And then at the end, and we're going to attempt to assemble all the parts together again in an assembly drawing, including the pedestal. So have a great time. Thank you very much. And